So far your programming has been very procedural. You take a method call, it returns back with data, and statements go line by line. However, most of the time in mobile applications, we really want to be waiting around. We want to wait for user input, or wait for a network call to return. So, how do we deal with asynchronous communication if it can't be something done step by step by step? Well, that's what we're going to go over now. If you take a look here in my activity, here I've created a new switch object. As you can see, my switch equals new switch. Well, when we actually wire a switch to a fan or a light, we don't want to turn it on or off at that moment. We just want to set up a situation so we can flip the switch on or off in the future and actually have the fan or light turn on or off at that time. So, here I have a wire up method. If we jump into it, you can see that it takes a switchable as a parameter. What this means is that as long as you are passing it something that adheres to the switchable interface, we can use it here. That advantage is huge because we don't need to know anything more about that particular object except for that it has a turn on and turn off method. We have this problem now, which is when you give us something to switch, we don't want to switch it yet. We want to switch it later, after this block of code is completed. So what do? Well, that's where this particular list comes into play. This is a list of switchable objects. And what's happening here is we're just saving a reference to the thing that was passed in. By saving a reference to this object now, this method can call turn on for any thing that has been wired up later. If we now go into abstraction activity, you can see, sure enough, 27 and 28 we're wiring up a fan and a light. But only on line 30 do those fans or lights actually have their turn on method called. This is called a callback. You'll often see this in other pieces of code, but with a different type of phrasing. You'll see register, callback, and unregister, callback. The same idea is wiring up a light or unwiring up a light. Anything that you register for, you need to make sure you unregister for. Otherwise, we could get a memory leak. By saving a reference, you're preventing garbage collection from ever deallocating that part of memory. So be sure to use your callback methods appropriately. By using this type of inversion of control, you can create code that is completely reusable in other projects because all you're asking it to do is adhere to an interface and remember the types of methods that it needs to call on those objects. Using this technique, you can wire up your code to respond to events in the future instead of just procedurally.